We're ready to go.
Perfect. Okay, excellent. Okay, everybody, thank you very much for joining us, and apologies there just for those minor hiccups in getting started. I'd like to welcome you to the fourth Soft Robotics debate. And today we're going to focus on looking at the impact of soft robotics. So considering should we be focusing on exploratory research versus application-oriented solutions, and what does the future of soft robotics look like, and how can we create a sustainable, rewarding and exciting research field going forwards? So quickly, just for some quick introductions, I'm Josie Hughes. So I'm a new assistant professor in mechanical engineering at EPFL today, and I will be moderating the debate for the next 80, 90 minutes or so. And I'm extremely delighted to be able to introduce 4 speakers today who are going to take pro and against stances to our kind of main question for the debate. So just to quickly introduce our speakers, we have Professor Elliot Hawkes, who's an assistant professor at University of California, Santa Barbara. Professor Oliver Brock from TU Berlin. Fumiya Iida from the University of Cambridge, and Professor Yong-Lae Park, a professor of mechanical engineering at Seoul National University. So thank you very much for you all for joining us. It's really fantastic to have some of your time. And one question that we're going to use to really formulate the debate, and we're going to ask you as the audience also to participate, is that in 10 years, will we still need soft robotics as a research field? And obviously we have the pro side, so yes, that soft robotics will become a distinct field of robotics with its own approaches, theories, and methods. Or we also have against, so no, soft robotics will just become a set of tools which are used broadly across the robotics research spectrum. Now, unfortunately, WebEx have decided to change their poll features, so we cannot ask this in a nice poll-like format, but it would be really interesting just to gauge the reaction of the audience at this point before we start the debate. So if you think, yes, soft robotics will become a distinct and will remain a distinct field, please raise your hand. Whereas if you think against and no, soft robotics will become just a set of tools which are used broadly across robotics, please leave it unraised, and we'll quickly count up, and then we can come back to this question at the end to see if the panelists have managed to sway or change your mind at all. Fantastic. So please keep those coming in, and then the wonderful helpers here will get those sorted. So it looks like out of our about 22 attendees, we have about a 50-50 split at the moment, probably just under raising their hands. So that's an interesting standpoint. So it's very much an open debate. So as I said, we're really going to focus on the future of robotics. And to start us off, I've asked the speakers just to prepare a couple of an opening statement on the question of, do we need a subfield of soft robotics? Why can it not just be part of mainstream robotics, or is the goal of soft robotics somehow different to that of this mainstream robotics field? And in the two sides of this debate, taking on the pro side that soft robotics is just robotics, we have Elliot and Fumiya. And on the against side, soft robotics should be discrete, we have Oliver and Yong-Lae. And they've very kindly agreed to take the extremes as we need on every debate to facilitate exciting and interesting debate and questions. So hopefully we'll address some provocative questions and come up with some interesting views. So I would like to ask each of the speakers in turn just to give a couple of minutes of their thoughts on the need for a subfield of soft robotics. And if that's okay, Elliot, I'd like to come to you first to give us a couple of minutes on why soft robotics should just be part of the robotics ecosphere.
Sure. Yeah, so I think, each of us might take this question a little differently. And one way that I'll go with it is looking at the goal of soft robotics versus robotics generally. And in my mind, if you kind of go to the highest level, the goals are not distinct in that robotics and soft robotics both are looking to advance automation for the benefit of the world, right? And so I would say soft robotics doesn't have a pass or something separate than robotics has, in that we're looking to advance these types of autonomous systems such that we can aid in whether it be manufacturing or healthcare or whatever the application in the end. The goals are not distinct. So in that way, you could see that the two fields don't have a separate goal, and so at least in one realm, you can imagine them being similar.
Thank you very much, and I think that's a really nice point to start with. So next, I'm coming to Oliver, who's going to open with why he thinks soft robotics is different from mainstream robotics. Over to you, Oliver.
Thank you. So first of all, I think it's important to notice that these fields actually currently are not the same, right? They have distinct conferences, they have distinct journals. And so if we're debating whether they should join or not, it kind of is almost like the question of a relationship where both partners need to decide whether they want to join or not. I think it's apparent now after a couple of years of a really big success story in soft robotics that the mainstream robotics community is not really adopting soft robotics tools in a kind of a widespread manner. So to me, that would seem that the other side is not really that interested in this marriage, if you want. And I think from the perspective of soft robotics, recognizing that soft robotics really, even though the goals are shared, in that regard, I completely agree with Elliot, the methods and the approaches are very different, right? In traditional robotics, the robot is just a tool, just like a computer program is just supposed to execute. In soft robotics, the solution is distributed between the robot and the software, the controller or the planner. And that's a whole different view that requires kind of a different perspective and sort of starting anew. So I would argue that soft robotics can advance much quicker if it's not held back by the baggage of old robotics.
Thank you very much. I think that's a nice controversial statement to end with. Thank you very much. So next, I would like to come to Fumiya, who's going to talk again on the pro side why soft robotics should just be part of robotics in general. Over to you, Fumiya.
Yeah, okay, thank you. So, I've been obviously enjoying soft robotics last 10 years. We're all excited about this and big fan of it. But having said that, if you think more and more about soft robotics, it sounds cool and it sounds fancy and it became a trend. But on the other hand, softness is not really the engineering term, right? It doesn't really mean anything specific from engineering point of view. Softness sometimes we call as talk about deformation or continuum body flexibility, physical contacts, and so on and so forth, and under-actuated system. So these are more like engineering terms. And if you think more and more about the details of soft robotics, there are lots of overlapping concepts between soft robotics and other robotics research, as represented by all these keywords. If you look at soft robots today, a lot of robots are a mixture of soft materials and rigid materials. And if you look at the rigid robots, many of them actually have a lot of soft components and soft skins and the sensors and rubber pad and so on and so forth. So in the future, my prediction is that these two fields is going to be less and less obvious, what's the borderline in between. And therefore, I think, everyone likes this concept of soft, regardless which, camp you belong to. But I think, from this point of view, it sounds cool at the moment, but maybe this magic mojo is going to disappear in the long term. That's my position at this point.
Mm-hmm. Thank you, Fumiya. And finally, to wrap up the opening statements, I'm going to come to Yong-Lae to talk against why soft robotics should be discrete from mainstream robotics. Oh, I think you're muted. We can't quite hear you.
Yeah, I'm very excited to join this debate too, because especially today's topic is something I've been questioning to myself for a long time, although I don't have a clear answer yet. But I think soft robotics is an excellent tool that can advance the field of robotics one step forward. Soft robotics, if you think about other fields of robotics, soft robotics is a little bit different from other robotics fields, such as legged robots, wearable robots, medical robots, and aerial robots. So all these fields have goals which are enabling and advancing the performance of those robots. But soft robotics is more like a powerful tool that could be implemented to all these robotics fields rather than a research goal itself. So I have one question to myself. Why do we really need soft robotics? So I think because by using soft robotics techniques, you can make robots safe and friendly to humans. You can make robots easily adaptable and interactive to environments. You can make robots more resilient and tolerant to impacts. So in other words, we can make robots useful to where they couldn't be used in the form of conventional robots. So I think soft robotics is a really powerful tool that can advance the field of the most of the entire robotics.
Thank you very much. Thank you very much all for those opening statements. And I think that's really interesting. There seems to be agreement among you that the goal is the same or very close to that of mainstream robotics, but it's almost the approach and the tools that are different. So I'm really interested in, why do you do soft robotics research? Because talking to a lot of you hearing, it's almost like soft robotics gives you the freedom to explore things that perhaps mainstream robotics doesn't. And it's also more of a kind of ideology or kind of a way of thinking, in terms of it allows us to think and talk more about embodied intelligence or distributed intelligence. So I'm really interested in, how did you get into soft robotics research? Where does that motivation come? Is it driven by funding? Is it driven by industry? Or is it driven by kind of intellectual curiosity for this research area? Would anybody like to start us off on that question?
I guess I can go if I was first before.
Please.
Yeah, so I think one thing that comes to mind, and actually this echoes some of what Yong-Lae was saying, and that the I don't always, not all my research is soft robotics, but often when there is a problem that I'm trying to solve, and I see that adding softness to my systems, I think can be advantageous, that's often when I pursue it. So so it's often a tool that I believe really can advance robotics research and lead to solutions that maybe are not possible with the tools that were around previously.
Thank you. And Oliver and Fumiya, to come to you, you've explored a lot of the robotics research area, not just in soft robotics, but a lot of other kind of domains or kind of sub areas of robotics. Why do soft robotics from your perspective? What makes it an interesting research field to investigate?
You want to go first?
Oliver, you go ahead.
Okay. So, I mean, let me come up with a comparison, right? I mean, basically, if you look at mathematics for a long time, it just worked with positive numbers, right? And because that was enough to count things. And then people discovered, well, if you just put a minus in front of things, and I'm simplifying, but you get incredible power to do all of a sudden quite different things. And to me, it's kind of the same, right? I was doing robotics, and in robotics, you always thought about, which robot am I going to buy? And then you bought the robot, and then the robot was that, and you were doing what you could with that robot. And to me, the insight that really that doesn't make any sense, that the robot contributes to the capabilities of your system exactly as much as the software, and that you're missing out on 50% of the equation if you don't also optimize your robot for your tasks. I mean, that was just completely convincing. And going down that road, it became so easy to solve problems that people had been trying to solve for 50 years beforehand, that it's kind of a eureka moment. And I would almost turn the question around: how come we didn't do this for 50 years? right? I mean, that is really the astonishing thing.
So what do you think triggered this? What enabled us to open up this world of soft robotics? Was it community engagement? Was it some examples? Was it frustration with technologies? How
For
did
me,
we come to?
it was Sue Whiteside. I saw one of his videos and was like, that's how it works, of course, right? I mean, it was just like you're not expecting to see the solution. It's right in front of you. Somebody points with the finger at it and says, that's the solution, and you're like, oh my God, that is simple, elegant, beautiful, explains everything. Thank you, right? So
Yeah.
so yeah, we were, and this is kind of a discrete event for me personally, but I think it happened kind of gradually. People were building hard hands with inherent compliance, right? And it's like, okay, you're arguing the compliance is why your hand is better than some other hand. Well, why don't you make it really compliant, right? I mean, why are you trying to build it out of steel if you're arguing that the compliance is the right thing? So in some sense, I think it happened gradually in the community. For me, it really was a eureka moment, and I mean, that's why we immediately built the softest hand that you could possibly build, because it's like, yeah, okay, let's go all the way. Let's see how far we can get by going all the way.
Yeah. Fumiya, perhaps I could come to you briefly on why are you interested in self-robotics research, other than it being a really interesting community and a growing kind of wave? Why is it interesting to you?
Yeah, basically I agree with what Oliver says, that the idea has been around. People kind of knew for a long time, right? The softness is important, although it's not really explicit. But then personally, for myself, I've been going to all this IEEE RAS big robotics conferences, for 10 years, 15 years. And every year we see, 2,000, 3,000 new papers in robotics, right? And obviously, lots of things are related or similar to each other. But, those topics that really interest me the most are somehow always related to materials. Like if you make a robot with a new kind of materials that people didn't explore, or people look at unknown things from biological system natures, and how we can make new ideas based on inspiration from nature and so on. So I think this was a kind of very fruitful field in principle, and the robotics and material science and robotics and the biology are really, really good fit. And this is a place where a lot of innovations happened for a long time. But then, I think all of a sudden people came together in this community that, okay, let's call this Soft Robotics. And that was the moment. I think that's a period in the last 10 years from my point of view.
Thank you. And Yong-Lae, I'd like to come back to you. In your opening statement, you very much mentioned these kind of application areas where we very much see in all these papers, we have these examples of where soft robotics can be used in terms of offering and utilizing the compliance. For you, are you motivated more by the applications and how we can use soft robotics to make a real difference in these applications? Or is it something more theoretical within the field? What motivates you to do soft robotics research?
One of the biggest motivation for me is biology. So what Fumiya said is something I was also going to say. Yeah, but if I add something more, structures and dynamics of biological systems are really amazing. So we sometimes say insects are one of the simplest forms of animals, but we don't understand so many things still, and then we don't even cannot make those systems or mechanisms. So we understand very small things, but by having these soft robotics technologies, we can try to mimic something similar to biological systems, and then we can try to understand those things. So biological systems are something that inspires the soft robotics. So, and in my case, I have both directions of fundamental research and application driven. So when I started soft robotics research 10 years ago, I first started making soft skin sensors, so highly stretchable, flexible skin sensors. At the time, I didn't know where to use, but I thought that's really interesting and really cool. And then I tried to develop stretchable sensors. But later on, I realized that could be used for body motion sensing. So you can attach those sensors to your body. And I also worked on pneumatic muscles integrated with sensors, which is really similar to biological muscles. So our muscles have embedded sensors such as muscle spindles and Golgi tendon organs that can detect your force and contraction of your muscle. And then I thought, oh, that's cool. And then probably we can make those kind of muscles in robotics. So I developed it, and then, but I didn't really think about the applications a lot when I made. But later on, we can find the applications of those muscles for wearable robots or some other soft robots. So I think fundamental research and application-driven projects come together, and then it really depends on the situation. Sometimes the fundamental research comes first, or sometimes the application-driven projects come first.
That's really interesting. So just to pose a question to you all, I think that's a very interesting point there by Yong-Lae, that we need to both have the fundamental and followed up with the application. But is that somehow limiting the field? Is that limiting our way, rather than picking one application and say, okay, let's come together as a community and solve this and demonstrate the strength of robotics? Is that the right approach to transform the way the rest of the robotics community think of soft robotics, by kind of slowly edging the technology out there and then transferring it to an application? Would we be better focusing on more application-driven technologies and approaches and using that as a means of engaging perhaps better with the mainstream robotics community and breaking down any barriers there may be to kind of transfer of both ideas and concepts there? Any thoughts from the others?
No, I think that's an interesting question, but I think I kind of like Yong-Lae's perspective on that it's maybe not an either or, but a both there, that we need both the fundamental research to kind of bring our overall understanding and principles forward, as well as looking at the end goals of, well, you know, how is this really going to be useful in the world, and how is this going to make an impact? And so I think what Yong-Lae is saying is absolutely right, that we need to take it from both sides.
But isn't the fundamental research in soft robotics kind of sensors, actuators, material science? And soft robotics kind of consumes their output and tries to do this in the context of a system? I mean, the question I guess I'm asking is, isn't it impossible to do soft robotics without with soft robotics, which is an integrated system of actuation sensing, without an application? Because you have to customize the hardware for a particular purpose, right? We have a computer, which is like a Turing machine that can compute anything. And that's why traditional robotics thought they have to build universal robots, which, you know, are devoid of their own dynamics, which are devoid of compliance, which are just executing what the universal computer computed. If we now realize, and I think, you know, we should, that the robot should not be universal, it should be tailored to something. That something is what I would call application. So I would say you cannot do soft robotics unless you have an application in mind.
But do you feel sometimes we give very tenuous in the papers? I'm very guilty of this. We say, okay, we could use this soft robotic for this perhaps application, and I feel sometimes we're shooting, or we're giving examples of where compliance or soft robotics could be useful without, we're using it as a means of selling fundamental research rather than actually solving applications. And it's a bit of a cheat, I feel sometimes, that we perhaps do.
Am I allowed to switch persona now, or?
Yes, please. Sorry. Yeah.
Because I mean that to me is the most important argument for bringing the two fields together, right? So I feel like in soft robotics, we take amazing technology, we take amazing materials, concepts. You know, I mean, soft robotics has introduced ideas into robotics that, you know, we're nobody thought about, right?
Mm.
And yeah, so we basically keep showing, look, this is possible, and this is possible,
Mm.
and this is possible, and because we know we have to motivate things, we motivate it with 5 applications. But showing that something is possible and making it possible are still two different things, right? And so I think yes, we should make more things possible. And I don't think we need to go directly to an application like every paper needs to go along with a company that sells to a million customers, right? But if we can sell it to the traditional robotics community as something that they would say, oh yeah, I mean, I've been thinking about this problem, and it's right. You're coming with this new idea, and you're making substantial progress. I think that would be a good measurement
Mm.
of making an intermediate step towards real applications.
Mm. Yeah, interesting. Yeah, Fumiya, sorry, Fumiya, any points to add on that, onto the kind of application versus fundamental kind of research?
Yes, yes, absolutely. Well, in my opinion, I think we should put more effort in application areas because in the fundamental research, we're going to do it anyway, right? These are fun and this is more interesting from academics' point of view, but it's a lot more nasty and a lot more difficult to do application research, how we can make our technologies useful and being used by end users, right? And I don't think we have really a single most influential application of soft robotics that all of us can be proud of so far. But this should, sooner or later happen. And after all, our research mostly, funded by taxpayers' money, and we should pay back at some point. But having said that, I said, this is really, really difficult things to make things happen in reality. So that's one of the homework all of us soft roboticists should think about.
Yeah. So it sounds like there's a general consensus that we need applications for soft robotics, and we can't really, as Oliver says, do this research without it. But should we be trying to compete with mainstream robotics? Should we pick the same goals? There was a science robotics paper on grand challenges. Should we be trying to compete with other fields within robotics, or should we be trying to find another application that kind of mainstream robotics can't compete? And should we compare? Can we compare the soft robotics and non-soft robotic solutions, or does it not even make sense to really do that?
I think at the highest level, the application level, I think we can have comparison and in the which solution works better, right, to solve a problem. I think often the ideal problem to solve, soft robotics might find a slightly different ideal problem to solve than a traditional robotic solution, and maybe that's going to be the best way to think about it, that there will be still things that are best to solve through traditional robotics, but there are going to be cases where soft robotics can outperform traditional robotics and kind of find niche areas of application that are really the best.
I'm not sure if it's just niches, right? I mean, we just published a paper at RSS about agent manipulation, kind of playing off the same demo, if you want, that OpenAI used, right? Which took like the hard robotics approach. They just bought a hand, which is not exactly hard, but they didn't optimize the hand, and then they just threw a huge amount of computational resources at it. And we did exactly the same thing, I would say, or more or less the same thing, maybe. Just with softness in the fingers, right? And our policy was super simple. Their policy had millions of parameters, took years to compute and so on. So I think, and by the way, OpenAI dropped their robotics unit. I wish I could take credit for it, but this is totally unrelated. But still, I mean, the idea is that you see the same thing happen in two extremely different ways. There's two realizations, and I think this is really eye-opening whichever realization you think is the better one, right? That's okay. But now we can discuss it because we now have a comparison of, if you want these resources or if you have these resources, you can do it this way. If you have the other ones, then you. So this is, I think, what we need. We kind of need a dialogue with old school robotics about what are the pockets of problems where one aspect or one approach is the more promising one, right? And we don't know the answer, but we should surely find out, I think.
Yeah.
Then the question I have is, when we solve the problem in robotics, so do we want to solve it? Do we want to have the exact solution, or do we want to have the good enough solution really fast? So do you want to solve the problem fast, or do you want to have really exact solutions? So in traditional robotics, we use feedback control and we use really precise modeling techniques. But in soft robotics, we cannot use those techniques a lot in soft robotics. But at least we can use the ideas, and you can use the mechanisms of those traditional robotics in soft robotics. So then, by using soft robotics, the Oliver set talked about the customization and tailoring in the application. But if you use soft robotics, I think it's really easy to customize those applications. And the really rapid growth and advancement of in soft robotics was possible because I think is involved with manufacturing techniques. So traditionally, we use this subtractive manufacturing techniques like machining techniques, but by having these additive manufacturing techniques like 3D printing, we can really quickly make prototypes. We can really quickly change the shapes and the parameters that enabled the growth of soft robotics, and also that made increase the usefulness of the soft robotics, I think.
No, that's a really interesting perspective that we have, that we control solve a different problem with different trade-offs, and soft robotics gives us a different approach. We can do it in a very flexible, rapid way, and so it's deciding which is the right trade-off for different problem, and as Oliver said, we can't always predict what's going to come out of there. And the other sorry, Oliver. Yep.
I just want to make one brief comment, because Yong-Lae basically said, "Oh, we can't model it exactly, but at least we can." So it almost sounded like apologetic, right? That we cannot model things exactly. I don't think that that's the right way to look at it. I think we need to point at the fact that it's not necessary to model those things, right? So we shouldn't apologize. Ooh, I'm sorry, I don't have an exact model of my. No, I don't need that model because my finger does something that I don't need to model, and it does exactly what I want, right? I mean, so this is always. I mean, I've had this conversation 100 times where people say, "Yeah, but your finger is soft. Can you do something precise?" It's like, you will define precise, right? Yeah, I cannot bring my finger to a micrometer into the position that you want me to, but I can put my finger exactly on the table, very exactly on the table, and that's, I think the kind of application that we want. If you're trying to position some end effector point in space up to a micrometer, don't use a soft robot. I mean, that wouldn't be the right thing to do. If you want to do other things precisely, like turn an object inside your hand very precisely, that is something that you can do much, much better with soft things than with hard things. So we don't need to apologize for not being able to model it. That's our strength. You guys, the fact that you have to model these things that are so complex means that you're taking the wrong approach to the problem.
And another thing I just wanted to add on is that we should really not distinguish soft robotics and non-soft robotics, right? Because this is the problem of academics. Like, we always think from our own discipline perspectives, but if you go to the real world, right? If you go to the problems of healthcare or medical or agriculture or whatever, they're just interested in problem. They're not interested in what solutions, what approach we should use for solution, but they want to have a solution, whatever, that is soft robotics or not soft robotics, right? So it's really dangerous if we start from, okay, let's use soft robotics or let's use rigid robotics, but we should really find out a solution, put all this possibility together, regardless if soft or non-soft.
Mm. Is there almost a problem with the naming of soft robotics as a field, because it's very divisive? It's not softness that we're talking about here. It's almost an approach and a focus on materials and kind of other component technologies, and also this kind of ideology that we have. Is there a problem almost with the naming, and is that creating this almost divide artificially? Should we think in the future, actually, rather than we still have what is now soft robotics, but does it just need a different formulation, both to aid us as researchers, so we kind of think a bit more widely, and also to aid with acceptance from the kind of the wider robotics community? Elliot, do you have a thought on that at all?
I would say that I think by naming it, we've been able to bring attention to it, and like Oliver's been saying, kind of have these aha moments for more and more researchers saying, oh, well, this is something I should really integrate into my robotics. And so it doesn't necessarily mean that it will have to divide out and be its own field far from robotics, but it by naming it, we can say, hey, this is a technique, this is a toolbox that you should consider and use to solve problems, maybe in a way that's better than you've done in previous decades.
Yeah. And so the next topic I was really going to focus on is, we've talked about the great things that we can do with soft robotics and the advances that are being made. But on the other side, what do we think is holding soft robotics back? We're seeing more and more examples of robotics in our daily lives, in industry, in far more applications. But there have been only a few, at least recent, translations of soft robotics research into really clear applications that are a real flag for soft robotics in the wider community. So do you think soft robotics is being held by something? Is it a technology? Is it kind of an approach, or is it kind of even just acceptance of soft robotics? Perhaps, Oliver, I can come to you this time.
Okay. Well, I think first and foremost, soft robotics is still close enough to robotics, and some people could say it's a subset of robotics that is predominantly held back by all the same things that robotics itself is held back. And to me, actually, that is probably the most relevant set of factors, so that we can almost ignore the soft robotics specific ones. And I think it is, I mean, I don't know if you guys know Berkshire Grey. It's a logistics company from the US that just went public a couple of weeks ago and is worth like, a couple of billion dollars. I think it's the first company, you correct me if I'm wrong, in robotics that went public since iRobot. Right. So I think, if we answer the question, why is that, we have also the biggest hurdles for soft robotics. And I think it's that really we cannot sell a component. We cannot sell, a hand. I mean, we were thinking about making a company selling robotic hands, but we can only sell to academics, right? I mean, who would really buy a hand if you don't have the perception system, if you don't have, everything set up, maintenance, right? So robotics is not ready to build systems that are capable and robust and reliable enough for them to be relevant for industrial applications, right? And functional. I mean, I should not forget the functionality, right? So I think that robotics had kind of this initial period of penetrating automation, where the robotics we knew how to do really did robotics automation well. But now, if we want to come up with more flexible, more generic robotic systems that also collaborate with humans, there's a huge jump in functionality required, and both at the level of building systems as well as at the level of having individual components. And I think on both of these counts, robotics in general is not far enough. And certainly with soft robotics, we have made building systems much easier. So I think we've pushed the frontier for all of robotics, but I don't think that we're actually managed to push it into an area where it's super easy to really make full-fledged industrial applications. You know, suction cups have always been around. That is soft robotics, right? And and they've been incredibly successful, and they continue to be successful, and people are rediscovering them, and are replacing kind of robotics with soft robotics to make systems better. But I think, you know, the gap to really having a killer app being possible is still too big.
Mm. And Yong-Lae, I think as coming back to what Oliver said about this kind of killer application and where we should go, I think there's obviously this gap in achieving that. But should we have a focus on something like that? Should we be thinking towards where at least should we be going with this kind of application-driven approach? What should we be targeting? Do you have any thoughts on what that application could be from your perspective?
My personal interest about soft robotics is by having soft robotics, I want to bring robots in our daily life. So when I was a kid, I saw movies and cartoons and animations. So you go out of home and then you see a lot of robots around you. But these days, still, I don't see any robots walking around you. I don't see any robotic dog walking with you, or I don't see any people who are wearing robots outside if you go out. So I think it takes time. If you think about the history of robotics, it's almost 100 years, but we don't really see robots in our daily lives. So the killer applications could be anything, but if we can bring the robots in our daily life, I think that could be killer applications, and then that could be enabled by soft robotics. So the first wearable robots was introduced by GE in 1960s, but you cannot really find anyone who's wearing a robot these days. And the first industrial robot was a Unimate, which was introduced in 1950s. And the first robotic surgery was done by an industrial robot in 80s. But in 2000 we first saw commercial surgical robots. So I think it takes really time, and I think it's been only just 10 years since we really started working on soft robotics. But I think we will see a lot of soft robotics technology in the future.
Mm-hmm. Yeah. Any other thoughts on killer applications? Any other focuses that you may have in your research groups that you think are really going to enable us to translate robotics to a more application-oriented, or to demonstrate the capabilities of the kind of robots we work on?
One quick thought is, you know, as Oliver's been mentioning, one of the advantages of the soft robotics is that we can remove some of the complexity of the controller and all this. And so one thing we're looking at doing is, for medical applications, building a soft self-deploying device. It's really not a robot. There is nothing smart about it. It's not having any sensing, but basically can grow. We have these little growing like robots into the lungs, so to do intubation. And so we found that this device can fairly successfully, in the high 90s percentages, find its way into the trachea, which is a much higher rate than something like an EMT has when trying to manually place a tube into the lungs. So maybe the higher level thought there is that maybe there are some applications where we don't need the full robotic system all working together. We can find simple, really simple soft robotic solutions that use this mechanical intelligence or whatever to solve a problem that is otherwise much more challenging to do robotically. And there are folks trying to do this robotically too, you know, using AI and active devices. And so there's that direction as well. But we find that the really simple system might have some place in the market.
Can I raise a question in this regard? So I think that we come from a culture where the body is supposed to be suppressed. where we basically, I mean, this the same way that robotics has looked um, at the robot itself. I think we look at our body, right? I mean, we try to kind of turn it into something that behaves. I mean, behaves not like a body, right? We use deodorant to avoid odor. We try to be super fit. We're like trying to shape our body. We train our kids to do very precise handwriting, right? It's not desirable that everybody has their own handwriting. We all need to write the same thing. In the army, people march, very much. So I feel like we have kind of a fear of the body doing something that is not intended by the brain. And in some sense, soft robotics is breaking that barrier. And we're turning matter that is regarded to be static and not acting by itself into something that we could even attribute intelligence to. Right. And I think as we move towards applications, one question I would have is this going to be something that freaks people out? Right. I mean, that all of a sudden, that they don't have scissors that do just scissoring. But they have something where actually you don't know exactly how it's going to respond in a particular situation because it's soft. I don't know. Is there some emotional or intellectual, societal boundary of acceptance that we are going to have to overcome with our systems? Because, I mean, can you imagine if every car you bought looked a little bit different, right? Or drove a little bit different? I mean, we would consider that completely low quality. Right.
Yeah.
So is there some kind of, sense of aesthetic or quality that we're going to have to fight against?
Mm.
And that's an interesting historical perspective, because like this standardization is something that kind of Industrial Revolution brought about, right? Before this, we had craftspeople, and each you'd raise your own cows, and your milk would taste different than the milk down the street. And so we have this huge standardization where you buy, like you say, you buy a jug of milk, and every jug of milk should taste the exact same, or else there's something wrong with it. And so
Right.
it's not something that has always been the case with humans, but it's the last couple hundred years. It's a really interesting point.
And Oliver, do you think you spoke at the beginning about this relationship between soft robotics and mainstream robotics? Do you think it's almost this trust, or is this one of the issues? Do you think why perhaps some of the remaining kind of robotics community is not necessarily that keen or that accepting perhaps of soft robotics? Is this an issue that we need to fix both within robotics before we even focus on the wider kind of public community?
I think that's possible, right? I think it's possible that soft robotics, because we don't have precise models of our robots, is kind of being put into a corner of, less serious science or more sort of hand wavy science, right? And and maybe to some degree that's actually even true, but that doesn't make it less science, right? So I think that there is some suspicion towards soft robotics, which, I mean, you guys correct me if I'm wrong, I think was part of the reason for starting kind of a soft robotics conference and for starting a soft robotics journal. And by the way, yeah, and robotics has that property, right? I mean, why was Coral started as a conference? Because the learning people felt like they were not seen or reflected sufficiently in the robotics community. So it's almost like we have a diversity issue as a metaphorical image in robotics, right? And
Yeah.
soft robotics is also suffering from that it needs to prove itself before it's welcome to the table. I'm not sure if what I'm saying is true. I'm just putting it out there to tell for people to say, if they agree or not.
Any other thoughts from the others?
I think the flip side of Oliver and Elliot's discussion is that one of the the main missing theories or technologies in soft robotics is how we can make soft robots more precise and faster, right? High speed, high precision. And I don't think there's any reason why soft robot has to compromise with the precision and speed, and we just don't know how to do it. And coming back to Josie's initial question, what is holding back? I think precision and speed is really holding back how we can make soft robots high precise and high speed, and then everyone happy to use it. We don't necessarily need high precision in modeling, but in robot itself should act in a very precise and very fast manner. And I think that will open a door for a lot of application if we solve it.
Hmm.
Yeah, I'm not sure. I'm not sure if that. So speed, I think we already have. I mean, maybe not at the same degree of performance as hard robots, which can, I don't know, go back and forth like 100 times per second, right? But you can do it at 3 hertz, right, with a soft robot, even if it's pneumatically actuated. And I think that's fast enough for applications. And with the precision, I would say the strength of soft robotics is that you achieve the precision in a way that's not driven by actuation, but it's driven by interaction with the world. And so you need to drive the interaction, but not the precision. The precision comes from the interaction with the world.
Yeah,
So
obviously, the speed and precision should be differently defined compared to rigid robots, right? Because if you have soft structure, you're not able to transfer the force, the high force, and you cannot really do fast speed and fast the good precision, just like rigid systems. So, definition of precision and speed must be different, but still, our robots, mostly soft robots, are very less precise, less fast, and we just need to really think about how we should really think of the controllability or precision, high precision control of soft robots differently from rigid robot, but still it's reliable enough that we can use it for applications or matching to a user expectation in the end.
Yeah. And this idea of, as we keep on coming back to the role of the body, I think is so fundamental to our soft robotics community. When we bring in new kind of researchers, new students, do we need to train researchers specifically for soft robotics? Or do we actually, is this a negative? Is this compartmentalizing it too much? And if we did want to train them, what is this about? Is it about kind of ideologies or concepts, or is it a very technical methods-based training? Perhaps Elliot, I can come to you again first.
Absolutely. So I mean, we have a soft robotics course at our school. So obviously, I do believe it is something that is worth the time. And I think there are certain skills and methodologies that we can add to a student's repertoire in a class like this, and understanding some of the maybe the more material science that they would not have gotten in a standard ME education, as well as some of the design techniques. I think that's another important part, is how to design when you're trying to design a body that is active or responsive. Is a different design problem than traditional robotics, where you're, like Oliver said, you're given the body and then you're just coding it. So yeah, I think absolutely some room there for education.
what do you cover in your class? Just curious.
Yeah, so we've divided it into 2 main parts, and so there's a hands-on component where we kind of work through the literature and build different devices from around the literature, so they get a hands-on experience in fabrication and design. And then on the other side, we do some very simple modeling, so pen and paper modeling to understand the basic physics of these systems. So these are models they can create in a class time hour or so to understand how do these systems respond, and how might you tune variables to increase performance at kind of a 0th order model of these systems. And then towards the end, they get to apply all that to make their own robot and see how it works. Yeah.
Cool.
Very nice. Any other thoughts from the opposing side? Are there any negatives to having a very kind of soft robotics focused education?
Well, I don't think we should have a soft robotics focused education. I think soft robotics should be on equal footing with, the rest of it. because you need both, right? You need knowledge of how to design the body, and you need knowledge of how to control the body, which requires knowledge of how to place or create and use sensor data, right? So I think soft robotics makes it more apparent than ever before that you need to combine all aspects of the whole sensor environment agent loop, um, to build a useful system. So I think we need all of these facets, and people need to understand how to put it together. I think the aspect is that people are coming with a pre-training. Like if they enter the PhD program, they're coming with a pre-training most often that didn't include any consideration of embodiment or softness or material in computation, right? For us, computation is something that happens on a computer. To say that the universal gripper is doing computation or is doing sensing, whenever I discuss that in my seminars in robotics, people get angry. I mean, like, how can you say that? That's just a balloon with coffee grounds. How can that do sensing? How can it do computation, right? But then when you discuss it more, it's like, yeah, I mean, it becomes impossible to distinguish it. And so I think that there's kind of a door that needs to be pushed open for people to see the potential. And it would be super, super cool if that would happen much earlier. So I would advocate we should go into high schools and teach kids, already that at that point to dream about designing the body and the software together, right? To teach them robotics is the problem of co-design.
Yeah. Any other thoughts on the topic of soft robotics education?
So I think when you talk about training or education of soft robotics, you also need to think about the applications. So I see soft robotics as a tool or method. So then there will be applications. So depending on what applications you want to use soft robotics, so the background knowledge and background education also should come together. So let's say if you want to make medical robots, surgical robots, and then you want to implement soft robotics technology in medical robots, then you have to know about where you're going to use the soft robotics. So when I first made wearable robots, which was assisting ankle motions, so before making robots, I opened the anatomy book and I just looked at how our ankle is moving and how the muscle is arranged in the body and in the leg. So after knowing those facts, I was able to start designing my first robot. So I think background research is also important for soft robotics.
Yeah. I think it's also this willingness to accept a more interdisciplinary approach and the willingness to look at different disciplines and not just be focused on the robotics community, but also the material science, the biology, and I think that's also part of the awareness that we need to raise in the education of students working in the soft robotics community. And that's, again, another thing that I think is fantastic about the soft robotics community is that it's more open, perhaps, to other disciplines, and then perhaps we could say mainstream robotics. And it allows us to interact and interface with a language which actually both ends can understand, for example, with biologists or with material scientists, whereas sometimes I think that's more challenging for both ends for kind of mainstream robotics. So I'm interested, what do you think about the kind of interdisciplinary aspect of soft robotics? Are there any target groups or communities that we should be engaging more with as a soft robotics community? And perhaps is this one disadvantage to soft robotics being absorbed by robotics, that it's no longer this kind of stepping stone or perhaps entry bar or even just way of communicating with other research communities that are not traditionally part of robotics? Perhaps Fumiya, I can come to you first on that one.
Yeah, okay, thank you. So yeah, well, one of the aspects of robotics is it's easier to build, right, and cheaper to build and faster to build probably. And that certainly lower the entry barrier to robotics in general, and you can go younger age education, or you can go to different discipline to start robotics, and that's certainly a contribution of soft robotics to general robotics. And then if you go down to the more precise control, faster control, or more application-oriented requirements, then you have to solve pretty much the same problem as other robotics doing. So I think, generally speaking, soft robotics is really lowering barrier for many people to join, and it really bridges the gap between conventional rigid robotics and everything else, right? So from that point of view, I think this is the really the big contribution of soft robotics so far, and in the next period.
Elliot, coming to you as perhaps some very much kind of pro absorbing the kind of communities, what do you think about the fact that the soft robotics offers this kind of easier entry point to other communities, and perhaps we could lose that if we lose this division?
Yeah, well, I'm not sure if we would necessarily lose it. I think one, more towards the question of, you'd ask which communities or do we benefit from interacting with, and one that has come up a couple of times today, and I want to highlight is the biology community, and working with biologists who really understand at a deeper level than us as roboticists, the principles and such underlying these ways that animals have solved really challenging problems of movement and manipulation and things like this. And so really interacting with biologists and bringing them into the collaborations, I think, can be a really powerful thing for this research area.
Oliver or Yong-Lae, any thoughts on the kind of what we're missing in soft robotics as an interdisciplinary community?
Yong-Lae, do you want to go first?
Sorry.
Sure, yeah. I'm not saying we are missing, but we still need a lot of interaction with computer scientists. So in soft robotics, it's really, we talked about this previously. So it's really hard to model precisely, and really hard to, it is difficult to predict the behavior of robots. And there are a lot of variations. So then these days, a lot of people are working on machine learning techniques to be implemented in soft robotics. So I think a computer science society or community can be really helpful for advancement of soft robotics.
One thing that I think would be kind of cool would be to have close interactions with the design community. I think we have good relationship with the material science and so on, but my feeling is I don't know if you guys know this little octopus robot, right? That was sort of completely autonomous. That looked beautiful, right? And I think the soft things that we do, they have also a dimension of designability that makes things. I mean, it would be easier to design something, right? We can have fancier shapes. We can have molds that have, I don't know, little knobs or whatever, right? I think it would be interesting to really get the design people to go crazy on our robots.
Indeed, that's a really interesting thought. Well, I think we're coming to the end of this. So I'm going to move on to asking all of the participants to kind of give an ending question and statement. And I'm aware we've strayed a little bit from the whole debate structure here, unfortunately. So I apologize for that. But yes, in coming back to it, I'm going to ask again the participants to kind of on the pro and against soft robotics being more part of robotics or its distinct fields. What should we try to achieve in the next 10 years as a soft robotics community? What should we have as a goal? And also, how do we know if we are successful? And in one extreme, is this actually meaning we're successful if we eliminate the need for soft robotics, for example. So if I could come to you in the same order again. So Elliot, I'll start with you if that's okay.
Yeah. So one thought as you know, when we're asking, you know, it's hard to say, you know, what are you going to shoot for in 10 years? And so sometimes I like to think about, well, what should you be shooting for on a shorter term? What are your shorter term goals that can lead to a long-term goal of a successful soft robotics field? And in my mind, it's really one thing that we can focus on is looking at each of our publications and making sure that we're advancing the field either within soft robotics or more broadly across robotics with each of those publications. And that's not saying that each publication needs to be you know, a breakthrough in changing the world, but you know, making sure that we aren't just reiterating things that other folks have already published, and really taking time to say, hey, is this a contribution to move the field forward? And so, you know, it's a little bit like, you know, if you're learning to play the piano or something, as long as, you know, it was always the hard part about that. And when as a kid, you know, to actually sit down each day and make an advance. And if you did, then, you know, by the time you got to your lesson, you would actually do well. Whereas, you know, if you just each day, you know, or say, oh, I'll just do it another time, then you never progress. And so with each of our publications, if we can make it a clear advance and say, you know, compare to where the field is and where you're bringing it, I think that can really help the field as a whole move forward to whatever direction it might go, whether that be its own field separating, but probably more likely in my mind, something that is integrated more with robotics as we move through this decade.
Mm-hmm. So you're proposing not constraining the direction, but just maintaining the gradient in that we are making stepwise advances, but we just let it evolve and
exactly.
kind of emerge.
Exactly. Yep. Yep.
Yeah.
That's a good summary.
Interesting. And Oliver, to come to you next on a different direction, if possible.
Okay, so now I'm supposed to take back the persona of yes.
Or whatever. Sum up as you feel best. I think that's best. Yeah.
So yeah.
Sorry.
So I think soft robotics will be successful if we have emptied traditional robotics. When all but the most theoretical roboticists have realized that their problems require components that need to be soft, and that kind of the soft robotics the soft robotics community imports the converted traditional roboticists. And how to achieve that, I would say, the way I described it earlier, we should take on kind of challenging problems from the traditional robotics community and show that either they're not necessary if you do it the right way, or that we can do them better if you incorporate softness, right? I mean, in some sense, if people don't want to believe it, we can show them, and I think we should. There are some smart people on all sides of all fences, and we need to recruit the smart people into the smartest corner of the room, and that's soft robotics.
Yes, indeed. And Fumiya, to come to you next.
Yeah, all right. The people overestimate in short term and underestimate long term, right? But 10 years is kind of in the middle ground. So I don't know whether we can do the good prediction or not. I don't think there's any Moore's law in soft robotics yet, right? But the one thing we could think of as a kind of the principle of a future prediction, probably something to do with the complexity of the system. Like if you count the number of actuators, number of sensors, and the number of other components, right? And then we will have more and more and more parts in one single system per volume or per areas or something like that. I think if this is the direction we go, I think soft robotics has a very good advantage that we are able to do the material approach of sensing, material approach of actuation, and so on and so forth. So we will have more and more actuators, but then the conventional rigid robotics approach, they might also go the same direction. And the more you think about the integrations and more components, then they have to go down to the material approach as well. So I don't know whether they're going to use deformable materials or something else, but in the end, probably going to have a similar common ground in 10-year time. This is a solution to make things really, really complex, like biological systems, and that's my view for next 10 years.
Mm-hmm. And just Fumiya, sorry to put you on the spot, you said 10 years isn't far enough into the future. Do you, let's say 50 years, do you have a vision then, if that's long enough, of what we should be aiming for on the very much on the long-term scale?
Well, I mean, I was talking about the complexity in the 50-year time scale, but I think in 10-year time, we already see it, right?
Yeah, okay. So the time scales we need to look on need to be longer. Yeah, thank you. And Yong-Lae, just to come to you last to wrap up really this question, your thoughts on the future goal and what does success look like?
Okay, yeah, so if I'm ambitious in 10 years, I don't want to see the term soft robotics anymore. So which doesn't mean soft robotics is obsolete or less important. So when you talk about robotics, we don't really say rigid robotics or hard robotics. We just say robotics. So we take it for granted that robots are mostly made of rigid materials and structures so far. But in a similar way, I think there will be a lot more applications in robotics that naturally use soft robotics technologies, soft materials, soft sensors and actuators and structures. So I think soft robotics should play a role like that. So when I was a kid, there was a very fancy technological word, which is a personal computer. But nobody says about personal computer these days. So, but we have computers everywhere. One person has several computers. You have a desktop, laptop, tablets, cell phones, but something like that. So I hope and I believe we will have personal robots in home, in school, at work, and even in playground in the future. And then I think soft robotics will play a critical role to realize those days.
Thank you very much all for your statements there. I think some really interesting views that we're going to see, that we perhaps don't know the exact direction. And I think, as Elliot said, we shouldn't constrain it, but we just need to make sure we are making advances, and we need to be critical on ourselves of doing that, and that it's almost in the complexity, and as Yong-Lae said, this kind of the versatility and the amount of soft robotics we see that is really important. So that's really interesting to see. Any final, having heard each other's statements, any other final points and any of the speakers would like to make? Nope. Perfect.
Just like to say thank you. Thank you for
Yes,
organizing.
thank you.
Yeah, absolutely.
Brilliant. Well, now it's just time to come back to all of those listening. Thank you very much for joining us. And just to return back to this initial question, so that the question is, in 10 years, will we still need soft robotics as a research field? Yes, it will become and remain as a distinct field, or no, soft robotics will just become a set of tools. So as before, please raise your hand if you are in the pro yes camp, soft robotics will become a distinct field. And we can see if throughout the debate we've kind of skewed the distribution of people in those views. So we'll just give that a moment to see those coming in. How are we doing? I think I'm seeing fewer hands up than when we started. Oh no. So out of the about 40. Yeah, so I think from a very, very quick poll and overview, it looks like we've reduced the number of hands up. So we've moved more to the no, soft robotics will become a set of tools used broadly across the robotics community. Yes, 4 out of 27 as yes pro. So yes, I think we've got a slightly reduced count.
Stay the same, no?
Oh, has it? Oh, wow. Oh, no.
It was
Oh,
9 out of 22, and now
22
it's
and then
9 out of 27. But probably 5
okay.
people have
Have left it.
stepped away from the computer.
Okay, well, that's good. Okay, hopefully, even if we didn't change your opinion, it was still a very useful and interesting discussion for you. So just to wrap up, I'd just like to thank you very much all for joining us. Thank you very much to the speakers in particular, and also all those involved in setting this up behind the scenes. So all those in the IEEE for running the WebEx and the system, and also for Marwa, Hadi, and Laura for really organising this fantastic series of debates and really setting up this initiative. I think it's really, really fantastic for the soft robotics community. So thank you very much for everybody for joining us, and I'm sure you'll all be back for the next 5th edition of the Soft Robotics debates. So thank you and have a good weekend.
Everybody stay soft.
Thank you. Bye-bye.
Bye.
Bye.